Hey, good afternoon, everyone. It's 1 o'clock. We've got mostly everybody's here. So I wanted to start off just with any questions. I know when we ended class last time, I had talked a little bit about sending you the problems for the homework because the system wasn't working properly, but then it was working. So did anybody have any issues, or has anyone had any issues getting into the online ebook or homework system? Everybody's been able to do that? Let me see, I'll look real quick to see how many, I can see how many students have actually done something.
I have been troubles getting in.
You've had trouble? You've
Yeah.
tried clicking, following everything we did on the, where you click on that red shell thing and get your course key thing? Did you do that?
Yeah.
Yeah. Is anyone else having an issue? These are the students that at least have logged in. So I'll look through this after class just to see who's kind of missing, and that way we can get that taken care of. Michelle, what's going on with you when you click on the link? It doesn't work for you, or what?
Nothing pops up. Just it just wants me to log into Pearson, and
So you did this setup first?
what setup?
Can you see my screen?
Let me see. Yeah.
So you're supposed to set it up first by going here, and then after that, you should be able to get in.
Let me see.
I tell you what, I don't want to take too much time on it. So if you want to try it after class, if it's not working, if we have some time at the end, I can help you out with it, okay?
Alrighty, thank you.
You can do it while I'm starting class, but either way, I want to make sure everyone's, in the system before the end of the week. Any other things that you want to discuss today? All right, so last time we were talking about rational expressions. We didn't quite finish that. We're going to do that. We're going to do nth roots, and hopefully we'll do solving equations today. It's a little ambitious, but we'll see how it goes. So when we finished finished last time, we were doing the rational expressions, and there were still a few problems that we hadn't done. So I'm going to start with that. We're going to work through these, and then we will start the new material. So here we go. First one is, oh, I didn't get the instructions here. Oops. Okay, here we go. So it says, perform the indicated operation and simplify the result. Leave your answer in factored form. So all they want you to do is perform the indicated operation. So first thing that we want to see here is that we have a set of parentheses. So we're going to try and simplify what's in the parentheses first, which means I'm going to almost look at this like it's its own problem. Let me give us some lines here. I'm going to take 6 over 3x plus h minus 2 divided by x. And I'm going to try and put these together, combine these into one fraction instead of 2. And to do that, I'm going to need a common denominator. So can somebody tell me what I need to multiply the first fraction by and what I need to multiply the second fraction by to have a common denominator? So I'll take a volunteer to start today.
You can multiply by the what you're missing.
Okay.
So pretty sure, right?
Yep, in this case, that'll work. So what's missing? What is this one missing that I'm gonna need here and here?
3 in the h. 3 x's in the h.
Well, this denominator has the 3x plus h, right? We need it to also have this one's denominator.
Okay,
right?
so now we're missing an x.
An x, right? So we need an x multiplied on top and bottom. And then on the other one, we need what was missing from the x, which is this denominator, right? So 3x plus h here and 3x plus h here. Now we need to do the actual multiplication. So we need to multiply those two fractions together, multiply those two together, and that means we just multiply straight across. So when I do this, watch what I do, because there's some little subtle things here. X times 6, that's 6x. On the bottom, I'm not actually going to multiply this x through. I'm just going to say it's x times this denominator. I'm not multiplying it through because it says in the instructions that I can leave it in factored form, which means I don't have to put those together. And then on the other one, I need to multiply the 2 through to this one. That means the 2 has to distribute to each of those terms. So I have a minus sign here. Then I have 6x plus 2h that's distributing up top. And then on the bottom, I'm not going to multiply through. Now you might be thinking like, why are you, oops, my minus went away. You might be thinking, well, why did you multiply through on top and not on the bottom? Well, the reason is because we have to put these together and they're going to have the same denominator, but I'm still going to need to combine the numerators together. So that's why I multiplied them all out, so I can easily combine the like terms together. So let's keep going here. This is going to be, let's see, I have the 6x, that's this guy. I have the minus, that's this one. And then I have to subtract that whole thing. So I'm going to put it in parentheses. And then all of that will be divided by the common denominator. All right, let's start calling on people here. All right, Hugo, are you here?
Yeah,
Hugo, are you following this okay?
yeah.
Okay. Can you help me just figure out what that numerator is going to be?
It's gonna be minus 2h.
Minus 2h, good. So all Hugo did there was distributed the negative through. The 6x is canceled, but you still had a minus 2h, and that's all over the common denominator, right? Okay, now Hugo, this is not the answer, right? This was just, we were just doing what was in that parentheses, right?
Yeah,
So that's just this right here. So now we need to go back and kind of finish the problem out. We had a 1 over h out front, and we're multiplying that by whatever we got in blue here, which is negative 2h over x times 3x plus h. Okay, Amanda, do you see what happens next? Are you there, Amanda?
Yes, sir, I'm here.
Do you see
I
what we can
believe
do?
you just cross multiply.
Are you saying like multiply across? Is that what you say?
Um, Or I guess they would, the 2h, the negative 2h and the h would cancel each other out.
Yes, the h's would go away. So you would have this h and this h reduce out. Otherwise, everything else is still there. You still have the negative 2. You still have the x on the bottom, and you still have a 3x plus h. And that would be the cleanest form of the answer that we could get. There's really nothing else we could do. We could distribute the x through, but like I said, it said leave it in factored form is fine. So that's it. Any questions on that?
So the numerator 1, it just kind of, is it implied or?
It multiplied, we actually multiplied the 1 times the negative 2 to get negative 2. All right, the next one that we want to do, number 12, there's only 2 more left in this section, 2 or 3. Okay, this one, perform the indicated operation and simplify, leave your answer in factored form. So what you're looking at here is called a complex fraction. It's a fraction that has fractions within the fraction. So it is somewhat weird looking. Remember we talked last time about the big division bar versus, you know, the small one. So this is a big division bar, which means I'm going to go try and figure out, you know, what is all of this first. After I figure that out, I'm gonna figure out what this is. And I'm gonna do that over on the side. So first, what is 2 plus 1 over x? So just like before, we need to put these two things together. That means they have to have the same denominator. So instead of writing 2, I'm gonna write 2 over 1. And that way I can see I have a denominator. And then I do the same thing that we did earlier, where we come in with something, we multiply top and bottom of each fraction by something. So Christopher, are you there? I don't see Christopher. Okay, how about Cecilia? Am I saying that right, Cecilia?
Yes,
Yes? How's it going?
good.
Good. Are you following along or? how
I
you
am.
feeling? What's that?
I am, yeah.
Okay, so we need a common denominator here. So what would you multiply this first one by?
X.
X on top and bottom. Now, the other one is a little bit tricky because, well, you tell me, what would we need on top and bottom?
A 1.
A 1, yeah. So you really don't need anything, but I'm gonna put a 1 here. And now, again, carefully, we're gonna do this and this. So Cecilia, do you want to tell me what I'm gonna get here when I put all that together?
2x over 1x plus 1 over x.
2x over 1x. I'm just gonna put x, if that's okay with you,
Okay,
plus 1 over x, like that.
yeah.
And then when you put those two together, what do you get?
3x over x.
Okay, so are you getting the 3x? Did you do 2x plus x, or
Like 2 plus 1.
you're doing 2x, right? This 2x, and you're
Yeah.
adding to it 1, right? But you
Yeah.
can't combine those because they're not like terms, right?
Okay.
If it was 2x plus x, then you would say 3x. But in this case, because it's 2x plus 1, you just have to leave it as 2x plus 1. There's really nothing else you can do. Does that make sense, Cecilia?
Yeah, that does.
Okay, and then now we have our common denominator. So that right there is what this is going to become. We have to do the same thing for the other fraction. So why don't we do this? I'm going to write it down. I'm going to get you started. And I'm going to give you about 2 minutes to see if you can put those two together. And then I'm going to call on somebody and we'll see if they got the right answer. And if they didn't, we're going to laugh. We're going to take pictures of our screen and we're going to like take pictures and send it to all our friends and say, look at this fool. 2 minutes. I'm going to go get a drink. I'll be right back. All right, hopefully that's enough time. Adam, you're up. Adam?
The answer, right?
I just want to know, yeah, what do you get when you put those two fractions together?
I got 9x minus 1 over x.
Good, okay. So everyone make sure you got that. If you didn't, put a little asterisk and then you ask me after class or something. That is correct. So now we're ready to rewrite everything, okay? So when I rewrite all this, I can say that this is equal to that first thing we found, 2x plus 1 over x, over the 9x minus 1 over x. And then we learned last class that when you have division of two fractions, it's equivalent to multiplication of the reciprocal. Meaning I can rewrite this as the top fraction times the reciprocal of the bottom fraction. So I can bring the bottom fraction up, flip it over. Don't forget to flip it over or else it's going to be wrong. Like that. Any questions on that property? And now hopefully you can see the x's cancel out, right? These x's go away. And so we're left with just the 2x plus 1 over the 9x minus 1. One common thing I see that's a mistake is that people will try right now at this point to cancel these x's. And you can't do that. And the reason you can't do it is because, well, first you have addition and subtraction right here, which means that you would have to figure out what all that stuff on the top is first before you do the division. And by canceling the x's, you're not doing order of operations properly. You're not doing all of the top first divided by all of the bottom. So that's dangerous. And it's tricky because, I mean, I understand it's tricky because if you had written down, you know, this, if you had just that, then you can cancel the x's. Okay, and it's because there's not an addition or subtraction on the top or bottom. So these are all those little subtleties I was talking about we need to be careful with. So that's our answer. So I want to show you, I talked last class about how there's different paths to get to the correct answer, right? Like some people might do one way, another, as long as you don't break rules. I want to show you a really like quick, easy way to do this problem, okay? Some of you might have already known how to do it this way. I'm going to multiply. So what I'm doing is I'm noticing that this has an X down here and this has an X down there, right? That's what I'm noticing. What I can do is I can multiply the whole top by X and the whole bottom by X. Okay, now you may be like, well, why? Just watch what happens. If I distribute the X through, I get 2X plus, now what happens when I multiply X times 1 over X? X times 1 over X, what happens? X cancel, right? That's the same as X over X, so that's just 1, isn't it? So I would just get plus 1, and then on the bottom, if I distribute the X through, I get 9X, and then from here to here, I get minus, and then again, the X times the 1 over X would cancel, and I just get a 1 again. Same answer, took me about like 1/5 of the time, maybe really fast. But that's not as natural of a thing to do. But now that you've seen it, maybe when you're doing a problem, you might try that instead.
Now, is that only with common denominators?
It usually works best when these denominators are the same. I think that's what you meant. Like these two are the same, then yeah, just go ahead and multiply the top and bottom by that denominator and just see what happens. All right, next one. Yeah, we have 2 more here. So I was joking a minute ago when I said I'm going to call on someone if they don't know it, we're going to laugh and take pictures and stuff. But you know, my daughter started a new school. She's been in private school her whole life, and she started a new private school, and the curriculum is different. What they've been doing is different. So she's trying to get like up to speed with everything. So she came home yesterday. She's really emotional. Like she's a 7th grader. She's really emotional about everything. She's always been that way. You know, she sees a dead frog on the road, she sits there and has like a little ceremony for it and stuff. Like she's just very, very big heart, right? So she came home, started crying that the teacher called on her and she didn't know the answer, and her teacher just kind of blew by her. And I was just like, yeah, okay, deal with it. Like, I mean, sometimes you're wrong, sometimes you know, you don't know. Okay, you know, it's not the end of the world. So the point is, you know, if I call on you at some point, you don't know, it's not the end of the world, right? It's just We want to learn and make sure that at the test, you're not still at that point where you're unsure. Okay. Wow, this looks weird, right? It's like weird, like stacked weird fractions, right? So I'm going to rewrite it to emphasize kind of what we need to do. I have a 1 and then I have minus, right? And then all of this, I can kind of treat that like its own thing. It's like 1 over 6 over x. Okay, so I just really want to make sure you understand that that really means this. Now, Amanda, on the previous thing, previous problem, you had mentioned, like, can you do that if they have the same denominator, right? And try this? I said, yeah, sure, try it. Well, notice here that they do not, like, there's not another one that has an x on the bottom, right? But let's try it. Let's just try that technique and see what happens. If I multiply the top and the bottom by x, let's just try it. Look, it's not illegal, right? Like, what I'm doing is not breaking a rule of algebra to multiply the top and bottom by something. Let's see if things get nice. So let's multiply x times 1. X times 1 is x. And then, let's see, Gregory? Is it Gregory or Greg? What do you prefer?
Either's fine.
What do you prefer? You have Gregory on your screen, so that's good.
Huh? Yeah.
Gregory's fine? Okay.
Yeah.
All right, so Gregory, what do you get when you distribute the x through the denominator like this?
You get x minus 6.
6?
Yeah.
Yeah, is that what I said? Yeah, x minus 6. So, you know, x times 1 is x, and then when you multiply the x times 6 over x, the x's go away and you just get the 6. And you have minus because of this. Okay, that actually worked out pretty nice, didn't it? It worked out pretty nice. Now we have to put these two together. So to put these two together, we need a common denominator. So I think I'll rewrite that 1 out front as 1 over 1. And now let's see, is it Josiah? Am I saying that right?
Yes.
Josiah, okay.
Yeah.
Josiah, what now? What do you think? What are you gonna do here?
You multiply the 1 over 1 by x minus 6 on
Over.
divided by x minus 6. Yeah.
Yep, so you're getting in that common denominator. And Josiah, what about the other fraction? Do we really need to do anything to that or not?
No, because it would just be
No.
multiplied by 1.
Yeah, you could multiply by 1 over 1, but I mean, nothing's gonna change, right? So
Yeah.
we'll just leave it. Okay, go ahead, Josiah, you're doing fine here. You wanna tell me what the next line's gonna be then?
Then you will subtract them and it will be x minus 6 minus x, which simplifies out to negative 6.
Okay, all over our common
Oh,
denominator, right?
yes. Over the
Yeah,
common
that's
top.
fine. So Josiah did this times 1, which was itself, and then subtracted the x. So I just wrote all that down. And then put it over the common denominator, which was x minus 6. And then Josiah, you said that the x is canceled out, right?
Yes.
You have an x, take away an x. So all that leaves you with is a 6 on top and an x minus 6 on the bottom.
Negative 6. Yes.
Yeah, negative 6, thank you. Negative 6 on top. There we go. Are there any questions on that? Good job. No? Okay, last one. Says here, an expression that occurs in calculus is given, simplify it. So they're saying that this is something like in a calculus class, this is something that you might run across, not this exact problem, but an expression that might look weird and kind of nasty like this. It's asking for you to simplify it, to try and clean it up, all right? So let's talk about the big division bar, right? We got this big division bar. So we want to try and see if we can't clean up the numerator first. Now, let me do something. You tell me if this is right. since I see an x squared minus 5 on top and bottom, can I cancel this and reduce that down to one of them? Am I allowed to do that?
No,
No, why not?
because the x squared plus 5 on the top is subtracted by another number.
That's right. Okay, I just realized I have 2 Josiahs.
Yes.
And didn't y'all tell me that last time or no? Y'all didn't say that last time, did you?
No,
know.
I don't believe so.
It's kind of unusual, huh? I mean, Josiah is a pretty uncommon name. They have 2 in one class. Off topic, but this will be interesting. There's only, how many of you? 15 of you here? This probably won't work, but we'll try it. Okay. How many January birthdays? If you're in January, if you're on camera, just raise your hand. January? February? 2 Februarys. Carissa, what day, if you don't mind sharing, what day? February what?
That's the 25th.
25th? Lizana, is that yours or no?
Mine's the 27th.
27th, okay. Any other Februarys? March? Okay, let's see. Josiah S, when, what day?
March 15th.
15? Michelle? 12th? Not the
March.
15th,
March 12th.
12th, okay. April? Just one April, May? June, oh wait, 2 Mays, okay, May what? Lorena, when's your
18.
18th? Reynolds,
Mine is May 2nd.
2nd? Do you think it's very likely that anyone's going to share the same birthday or not? Do you think that's very likely? Okay, July, where are we, July? Where are we? I forgot where we were.
June.
June, okay, any Junes? July? August? Me too. August when?
5th.
5th? Hugo?
The
28th.
23rd.
23rd, mine's the 31st. Oh, happy birthday, Hugo. 2 days
Thank you.
ago. Yeah. Okay. September, any Septembers? Juan, when's yours? Do we have any other Septembers? No? October? November? Okay, 2 Novembers. Tabby,
Mine is on the 30th.
30th. Desiree?
Mine was for October. I clicked
Oh.
it late.
Okay, okay. So when is yours in October?
October 4th.
Does anyone have October 4? No? So we did November, December? Okay, so it didn't happen. No one shared a birthday, it doesn't look like. Do you think that's unusual, or you think that that's pretty highly likely that that was going to happen, like no one had the same birthday? Pretty
Highly
likely?
likely.
Fairly
Pretty
likely.
likely.
Yeah. So it turns out that if you put into a room 24 people randomly, the chances that 2 people share the same birthday is 50-50. It's a coin flip.
That's
It seems
ridiculous.
weird, right? Does that not seem strange that it would be that high of a probability, which is 24 people? So normally when I do this, it's usually in a face-to-face class, and I usually have like 30 students in there. And so like, it's a pretty good chance that 2 people are going to share the same birthday. It's not a great chance, but 50-50, right? It's a coin flip. So when it happens, like people are like, what? You know, they freak out and stuff. And I'm like, it's actually statistically not that big of a deal. But it just seems unusual. Why am I talking about that? I have no idea why I'm talking about that. I apologize.
Me, my husband, and my daughter all share the same birthday.
Really?
Yes. It was a great birthday gift.
Yeah, I'm not quite sure if I would like that. My wife and I, our birthdays are like 3 days apart, and mine's before hers. So like as soon as my birthday comes, I already have to be thinking about hers. And like she gets like a whole birthday week and I just get like 1 day.
That's usually how it goes.
Yeah. Well, at least you're all celebrating together, right? Equally.
Yes, one big bash.
Yep. Okay, so back to this. I was asking, can we cancel those? And the answer is no, and it's because we have this subtraction right here. That subtraction creates two different terms on the top, and so you cannot cancel. If that ever causes you problems, like why you can't do that, you can give yourself a simple explanation why. If I ask you to do 5 minus 3 over, let's say, 5, okay? Then you do the 5 minus 3 first, that's 2, and 2 over 5 is 2/5, right? But if you cancel the 5s, then the answer is -3. So which one of those is correct? What seems more right to you? That's the idea, is that we can't cancel those because you have to do everything up top first before the cancellation. I hope that makes sense. Okay, so looking up top, I swear there was a reason I brought up the birthday thing, but I can't remember why. All right, so here we go. I look at that top and I see a bunch of stuff and I need to do order of operations. And I don't think we talked about order of operations, did we? I think we did, didn't we?
Yes, last
I gave you
class.
that problem. Remember that problem that I gave y'all? Where I took a poll? Didn't I take a poll?
I believe so.
Yeah, I took a poll. So we do have a very distinct order of operations on how we do things. So we are going to do these multiplications first. Okay, so that means I need to multiply these two together, multiply those two together. After that, then I can subtract. So multiplication of this 3 means distribution. Multiplication of the 2x means distribution here. So with that said, let's go with Gloria. Trying to get through everyone today really quickly. Gloria, what happens when I distribute that 3 through the first parentheses? Gloria here. Gloria, no Gloria. All right, Juan, you're up.
Yes.
Okay. I'll erase all this so it's not in your way. So tell me what we get when we distribute the 3 through.
I got 3x squared plus 15.
Plus 15, okay, and then minus. Now I'm going to ask you, Juan, how would you do this? Would you distribute this and then apply the negative sign, or would you just put everything in parentheses and then do the negative after? Like you personally, how would you do it?
I would just do it right away.
Okay.
Minus 6x squared.
Okay, minus 6x squared, and then your next term would be what?
Minus 4x.
Minus 4x. Okay, so that's a very subtle thing, but important. Juan kept the negative out there, did the distribution, and distributed the negative as he went. You could just put it all in parentheses and distribute after. That's kind of up to you. The more comfortable you are, the easier it is. Well, the more comfortable you are with it, the faster you can be with it. And then now we're ready to clean up the numerator. We can put those two together. That gives us -3x squared. And then those, oh, we can't put the 15 with anything. So we have minus 4x and then plus 15. So that's all we can do up there. Then on the bottom, x squared plus 5 squared. There we go. Any questions?
Is that where we stop?
Yeah, I mean, unless we can do anything else. And the only other thing we might be able to do is maybe factor the numerator. Maybe. It could be that factors and then maybe it cancels, but it's not going to. You can try factoring this by what we did last time. So multiply -3 times 15, that gives you -45. And then put the number here, -4, and then try and come up with two numbers. But I do not think it's going to happen. Is it?
No, it doesn't.
What about 9 and 5? It's 9 times 5.
And then 5 would give us 14 for adding it.
Yeah, for adding. So it doesn't quite.
Use a -9.
How about -9 and 5? Would that work? Maybe that does factor.
It does factor, but it won't cancel out the denominator.
But it won't cancel. Okay. So as long as it doesn't cancel, it's okay if you leave it unfactored. That's all right.
Think I did it, I did the homework and I put it like that. And then
Uh-huh.
want me to factor it and then
You
it's.
did want, you
Yeah,
did
no-
want it factored?
Yeah.
It doesn't say that though. So on a test, I wouldn't mind if you left it like this, as long as nothing canceled. It'd be okay.
Would either answer be okay though if we were to put it on a test?
Yes, that's what I'm saying. On a test that you take with me, because remember, the tests are going to be paper pencil tests, you know, whether or not we're back on campus or we're doing Zoom, either way, you're going to be submitting handwritten work. Okay, that completes the problems from that section. So according to our schedule, we have now taken care of, well, we never talked about the algebra essentials or polynomials, but we have discussed the rational expressions. And now I'm going to get into nth roots and rational exponents. I'm going to try and go quickly through this because I really want to get to solving equations today. If we don't, we don't, but it would be ideal if we did. Okay, so I'm going to do this the same sort of way that I did the other section. The other sections, I'm just going to kind of work through the homework. So the first question here is to evaluate these two expressions. So this is just making sure we understand how important parentheses are when we're squaring something. So the first one here, well, let me ask. Let's see, Josiah S.
Yes.
Okay, so what are the answers for those? And can you kind of explain why they're that way, or how do you feel about that?
Well, the first one is 25 because
25.
-5 times -5 is 25.
Because -5 times -5 is a negative times a negative is positive, so you get 25. I agree. Okay, what about the next one?
It will be -25 because
Can you explain that?
you aren't squaring the negative symbol in with the 5. So
Yep, perfect. So we're not, it's very important when you write -5 squared, really what we mean is this, -1 times 5 squared. That's really what that means. And so the squared is really only acting on the 5. It's not acting on the -1. So you're squaring the 5 times 5 is 25, but then you're multiplying it times -1, which gives you the -25. That's extremely important, extremely important. Those are little things that come back and haunt you. Okay, the next thing is to rationalize a denominator. So what is rationalizing a denominator? Has anyone ever heard? I'm sure you've heard of it, but can anyone explain what we mean by rationalize a denominator? Like what is the goal? What are we trying to achieve? What are we trying to do? Have y'all heard that before? Rationalize?
Isn't it when you multiply by like 1 plus square root of 3, both sides?
Yes, that's what we're gonna do, right? That's what it'll be here. But my question is, what are we doing? Like, you know what I'm saying? Like, why are we doing that? Like, why are we, I mean, go ahead.
Sorry, isn't rationalizing it just getting rid of the radicals?
The radical where?
The square root?
Yes,
In
we
the
have two
denominator.
in the denominator.
Because
In the
we
denominator.
can't have a radical in the denominator, right?
Okay, so that's what I was hoping somebody would ask me. We can't have a radical in the denominator. And that's why we're doing this, right? That's probably what you've heard in your past. Like rationalizing a denominator means making it so that you no longer have a square root in the denominator. Okay, the question is why? Someone told you you can't, but why? Because it's not true, you can't. So why are you told you can't? All right, so there's two things about this that I want you to understand, all right? Whenever my students get to calculus, if they didn't have me for algebra and I tell them this, they're like, well, I was told we can't, and then I tell them you can, and they get kind of mad. So I want to give you a quick little brief, like not It's going to be a brief little lesson as to why this is all kind of BS when it comes to rationalizing the denominator, all right? So let's go back, let's look at an expression, all right? Let's look at the expression 1 over the square root of 2, all right? You have probably been told somewhere in your life that you cannot leave this answer this way because there's a square root in the denominator. So you're told that you need to multiply by the square root of 2 over the square root of 2. And well, square root of 2 over square root of 2 is really a 1. So we're not changing the problem. We're just multiplying by 1. It's going to make it look different. So let's go ahead and do that. 1 times this, that's square root of 2. And then when we do the square root of 2 times the square root of 2, what do you get? What's root 2 times root 2?
You get a 2.
Yeah, it's just the square root of 2 squared. So the squared and the square root go away and you just get the 2. So you get a 2 on the bottom. And then everybody gets happy because now you no longer have a square root in the denominator and you've done what you were told, right? But my question is still why? Because if I get on my calculator right now, and if you do the same, if you type this into your calculator and type this into your calculator, you're going to get the same exact answer. So why have you been told you can't have a radical in the denominator, right? So why, right? I'm not even going to ask you to guess why, because I don't think you probably would never guess why. You have to understand the history of things, all right? So does everyone understand that those two expressions are exactly the same? Got it? Yes? One has a root in the bottom, one doesn't. Okay, let's go back in time before calculators, okay? Before calculators. Mathematicians, students, right, would come across numbers like the square root of 2, pi, e. There's a bunch of like important numbers in math. And anytime you have an important number, you don't have a calculator, students would have to memorize these numbers. Okay, so back before calculators, if you were taking math, you would have to memorize what pi is. And I think a lot of us know pi is about 3.1415. And everyone kind of knows pi out a certain number of digits. And there used to be contests back before calculators, like it was a measure of like how big of a nerd you were, like how many digits you knew pi, really, seriously. So like one of my colleagues, he's 70 years old. He at one point knew pi out 120 digits, and he can still go out at least 60 digits of pi. He has it all memorized. So that's what they had to do back in the day before calculators. If there were like square root of 2 would come up a lot. So they'd have to memorize it. It's 1.414. Okay, they'd have to memorize that. E, they'd have to memorize it's 2.718. Right? So that's all in their brains, right? They're storing it. So then they would be working on a problem and they'd come across this, 1 over the square root of 2. Right? And they need to figure out what that is. So let's think about what this would require. Well, first, they've memorized that the square root of 2 is 1.414, right? They have that memorized. And now they try and do old school division, right? Remember old school division where you go division box, you put the numerator in here, you put the denominator on the outside. I cannot write 1.414 for some reason, right? And then you have to try and start figuring out how many times does 1.414 go into 1? I don't know. How many times 1.414 go into 1? I have no idea. Do you? Without a calculator? Right. I saw you going for it, Carissa. Right. So this is not easy, right? That's not easy. But rationalize the denominator. So we already know that if you rationalize the denominator, it now looks like this, doesn't it? But this, the student would know is 1.414 divided by 2, right? It's a little different. It looks a little bit different than this. But when you go to the old school division, the 1.414 goes in the box, and the 2, a nice number, is on the outside. And now when you go to try and divide this, you say, okay, 2 doesn't go into 1, so I put a 0 here. Okay, 2 goes into 14 7 times. Bring down a 1 4, subtract. Do you understand? Like, this is much easier to do by hand. And that would always be the case if you have a square root on the bottom and you try and do this, your square root thing's going to be on the outside. But if you rationalize, then your square root's up top, which means it'll be inside the box and the nice number will be on the outside, and it's much easier to do. That is the only reason why you need to rationalize the denominator. That's the only reason. Now, that sucks because you've been told that you have to. So that's kind of like the thumbs down about this. The reason we still have to do it here is because if you replace the numbers with variable expressions, we still need to know how to execute the technique. So like if I want to do something like 1 over the square root of x plus h, and I want to do something with that expression later in calculus, I do need to understand how to rationalize. So it is a useful technique, but there's no like rule that says you can't have a square root of a number in the bottom. Like, throw that out. That was taught to somebody, it was taught to someone, and it's just followed through history to where we are now. Okay. You know what? I don't think I did show you, did I? No, I didn't show you the other thing. This one, 16 divided by 4 times 2. I didn't show you that. This is another example of where historically things kind of went off the rails. So let's do a quick poll. I'm going to give everyone about 30 seconds to give me an answer to that. So here's what I want. There are 2 choices. I sent the poll out. Choice 1 is the answer 8. And choice 2 is the answer 2. So do you think that this is 8 or do you think that's 2? Jeopardy music in the background. Okay. Do y'all have a guess as to like what the percentages are here? Like how many people think it's choice 1? How many people think it's choice 2? Anyone want to guess what the percentage is? Take a guess, come on. How many, like what percentage of the class do you think chose 8?
Probably like
33%.
How many? What is that?
30%.
30%, you think? 30% here? That would be
I would
70.
actually say the other way.
Think the other way?
Yeah, I would actually think it's 70% choice 1, 30% choice 2.
Yeah. Well, I'll share the results with you. It's actually 36%. 36% and 64%. Okay, so I'm going to ask a volunteer from the majority. The majority of you thought it was 2. So any volunteers from that majority to kind of like justify their answer?
I thought it was 2 because of PEMDAS. I'm sorry, Gregory.
It's all right. Okay, what do you mean PEMDAS?
Because I learned that you should always multiply before dividing.
So what does the P stand for?
Parentheses,
Okay,
exponents, multiplication, division, addition, subtraction.
okay. So most of us have seen this PEMDAS. So I think you're following it, right? Gregory, are you agreeing with that? Okay. And I would say 64% of you are pretty much following that. Okay, good. Now the other, the minority, the 36%, anybody want to justify their position?
It shouldn't be multiplication first. It's the first that comes from left to right.
What?
It should
Yeah, because the people that chose the second one are doing it backwards. It's multiplication first and then division. If you got 2, you did division and then multiplication.
So if you have both division and multiplication, you always do division first.
No, multiplication.
Don't
Multiplication
you
goes.
start from left to right?
Yeah, okay, so look, this is answer, the correct answer, drum roll. The correct answer is 8, all right? So that already goes to show you the way things are taught. Sometimes, I'm not gonna say it was taught wrong. Maybe just, you didn't hear it correctly, or maybe it was taught wrong. I was taught wrong, okay? So whenever you look at PEMDAS, multiplication, division, and addition, subtraction are not done in that order. They're equal. So multiplication, division are equal. Nobody gets preference. There's no preference. Multiplication is not before division. Division is not before multiplication. It's always left to right as you read it. Okay, so here we have multiplication and division. We do not do the multiplication first because if we read from left to right, the division comes first. So we have to do 16 divided by 4 first. That's 4, then times 2, and then your answer is 8. And that is the correct way to do it. So 64% of you learned something new today, right? So just be careful. What I'm trying to get at here is that you have to be careful with the way things are taught, because sometimes, unfortunately, we're human, right? Things are taught and it's not correct. So like when someone tells you you can't have a square root in the bottom, that is not correct. You can. It's just if you have to do it by hand, your life's going to suck. So you probably don't want to do that. We have a calculator, so we don't care, right? I can do 1 over the square root 2 on my calculator. I'm done. I'm ready to move on. So anyway, okay, back to what we're doing. We want to rationalize this denominator. So this is where we are going to be emphasizing the fact that we are looking at more of what the technique is here, as opposed to being like, why do we have to do this? We would just want to know how it's done. Okay, so in this problem, I have 2 terms in the denominator, right? You see them separated by subtraction, 2 terms. Whenever you have 2 terms in the denominator and one of them is a radical or a square root, then what you have to do is multiply this by what's called the conjugate. And the conjugate is just the same thing you see on the bottom, but with change the sign between them. So that's called the conjugate. Conjugate. Okay, the conjugate. So I take this expression, I just change that minus to a plus. If this had been a plus, then I would have put a minus here. And what I'm going to do is multiply the top and bottom by that. So let's do the top first. When I multiply through, let's see what we get. Root 2 times 1 gives me root 2. What is root 2 times root 3? It's going to be plus, but what is root 2 times root 3? How do you do that? Root 2 times root 3. What does that become? Anyone?
Root 6.
Root 6. You just go, you multiply the 2 together, you put them under one root, and it becomes root 6. So this is going to be root 6 over. Now on the bottom, we have to do that good old fashioned FOIL thing, right? This times this, which is 1. This times this. So 1 times positive root 3 is positive root 3. And then when we do the middle multiplication here, we get a negative root 3 times 1, which gives us negative root 3. And then the final multiplication is the one you have to be careful with, this one times this one. Because it's a negative times a positive, you get negative. And then root 3 times root 3 gives you root 9. And root 9 is 3. I'll write root 9, just so I'm going to have to write another line anyway. So root 2 plus root 6 over 1. Notice that the middle terms cancel. And all you're left with is minus 3. So square root of 9 is 3. So root 2 plus root 6 all over negative 2. There you go. Questions?
For the numerator, could we have combined root 2 and root 6 into root 8?
Yeah, can you? I don't know. Can you?
Great question.
Good question. So let's try and convince ourselves whether or not we can. All right. So the question that's being asked is, can root 2 plus root 6 become root 8? That's the question. So look, I told you all a little bit about my history in math, right? Like, you know, I struggled at some points in my life with math. So when I would run into things like this, I would try and convince myself whether or not that logic made sense. And by doing it, in doing that, what I would do is give myself an example that was easier to work out. So I would give myself an example like this. I would be like square root of 4 plus square root of 9. Okay. Instead of this problem, is that equal to the square root of 13, right? Because that's what you're doing here. 2 plus 6 is 8, right? So is the square root of 4 plus square root of 9 13? The square root of 13. So I'm wondering, is it, right? But see, I intentionally did square root of 4 because I know that's 2, right? And I did square root of 9 because I know that that's 3. And I know that 2 plus 3 is 5. And I know that that's not this, right? So that means I must not be able to do that, because then that would have made sense. Is that clear to you?
That checks out. Yeah. Okay.
Yeah. So I would say that, you know, if you ever run into issues where you're not quite sure about the algebra, just try different things to convince yourself. Eventually you get, the rules just get kind of burned in, you're okay with it and comfortable. But until then, try something like this. Okay, so we can't do anything there. I do have a question. Can I do this? Is this the same answer? Is this okay?
No.
Yes.
The negative that was on the bottom, can I just slide that out in front of the fraction like this? So I heard some yeses and nos.
Yes.
You can, all right, you can. Could you do this? Is that the same?
Yes.
Yes. So what's going on here? Okay, so what's going on is this. Anytime you have a fraction, doesn't matter what the fraction is, if you have a fraction, A over B, if you have a negative sign, the negative can be on the top, or you can put the negative on the bottom, or you can put the negative out front. It does not matter where the negative is. You're free to move it around, all right? So on this first one, the negative was on the bottom. Okay, great. The second one, I moved the negative off the bottom, put it out front. That's this. And then on the third one, I took that negative and I pushed it to the top, which means it had to distribute through both, and that became this one. So these are all the same answer. You're going to see little things like that as we move through the algebra here. You're going to see things like that. I just want to make sure everyone's clear as to why I'm doing it, why I'm allowed to do it. Questions? All right, we're moving on to what are called rational exponents, or sorry, not radicals. What am I talking about? Remember, this is review, so I'm not like formally introducing this stuff. Okay, so we have this thing, this cube root, right? This cube root. So the cube root means that anytime we have, if I want to take the cube root of, let's say, x to a power, let's say 5, the cube root means that any group of 3 that I have can be pulled out. I can rewrite x to the 5th as x to the 3rd times x squared, and then I can split that into 2 cube roots. And then the cube root of x cubed is just x, because they have the same root and the same power. So this just turns into x. And then I still have next to it the cube root of x squared. So this is just kind of a problem to kind of remind you of how cube roots work. So how about this one? Is there a way that we can rewrite negative 125 as something cubed?
-5 cubed.
-5, good. Cubed. -5 times -5 times -5 would be -125. And then I'm going to rewrite the x to the 5th as x cubed times x squared. And all of this is underneath the cube root. Now, anytime I see the cube here, cube here, cube here, that means that this can be broken up into different cube roots. You don't have to do the step, okay? I'm just trying to show as much detail as possible here. So I'm splitting this cube root into 3 different cube roots. And now this first one is -5. This one is just x. And this last one you can't do anything with, so it's cube root of x squared. So that's our final answer here. Are there questions on that? I'm doing some properties of exponents here. Are there any questions on this? There's not a lot of problems for this section, so we're gonna move quickly here. Okay, next one, simplify. So this kind of goes back to the question that I think Josiah Reynolds asked. And, you know, can you put these 2 roots together if you have addition between them like this? And the answer generally is no, unless what's underneath the square roots or underneath the roots is exactly the same. So to try and do this problem, what I'm going to do is I'm going to see if I can break down 175, and I'm going to see if I can break down 63. So let's see, let's try the 175. Is 175 like something, some perfect square times something, or no? I'm trying to do what we call the prime factorization. So let's see, if I get my calculator out and I do 175, let me divide it by 5. I know that this is 5 times 35.
35.
Right? And then that can be broken down to be 5 times 7. And 7 can't be broken down, so we have 5 times 5 times 7. That's what 175 is. So that means I can rewrite this as negative square root of 5 squared times 7 plus 2. Now let's break down the 63. How can you break down 63? Not 9 and 7, right? 9 and 7. And of course, 9 is 3 squared. I say, of course, yes. And so this breaks down to be 3 squared times 7, like that. Now, again, I'm going to show more detail than I necessarily need to here. This is square root of 5 squared times square root of 7 plus 2 square root of 3 squared times square root of 7. So I'm splitting this into 2 roots, splitting this one into 2 roots. And this gives me -5 root 7 plus, what is this going to be? Who wants to tell me what that's going to be when I put that together? I have 2 times, yeah, 2 times the square root of 3 squared. So this thing turns into a 3. So what do you say it's going to become? It's going to be a 3.
It's gonna be 6.
6 root 7, right? Now, can we put those together?
Yes.
Yeah, they have the same root, right? So the way I look at this is like you have -5 apples and you're adding 6 apples, right? So how many apples are you going to have?
One.
1. So we're just going to have 1 root 7. We don't need the 1 in front here. It's implied. Okay. Questions? let's do this one. This will be the last one we do. For this section, sorry. Simplify the given expression. So we want to take the square root of x plus 6 and we want to square it. Right? We want to square that. So what's the big mistake that people make here? People will say that this is x plus 36, right? You see what they did? Just squared each one and that was it, right? That's wrong. You have to do square root of x plus 6 times square root of x plus 6, and then you have to FOIL it. So if we multiply this out, we get this times this. What's that going to be? Let me see. I need to continue getting through everyone here. Michelle, what do we got here?
Would that be 2 square?
What's that?
Would that be square root of 2?
When I do the root x times root x, that's root x squared, right?
Yeah, square.
Okay. And then what happens when you square a square root?
They cancel out.
Yep, they cancel out. So all you're left with here is just x, right? That's that first multiplication from here to here that gives you x. Now, how about from here to here? You have root x times 6, but you're adding it, right? So that should just give you what? Michelle, what do you think?
6
times,
the square root of x.
yeah, 6 root x, just like that, right? And when we do the middle one, again, we're going to get another 6 root x. And then we do our last multiplication, 6 times 6, that gives us 36. Now, this would almost be done except for the fact that these two are like terms, right? Those both have a root x. So I have 6 apples and 6 apples. I add those up, I should have 12 of them. That's it. Okay, feel good? This completes the review, all right? Everybody is at a different place, I understand that. Now we're going to get into, I guess, what would be considered to be new material, although I know that some people, there are some things, aspects of this that are not new, it's just the way we're applying things is new. We're going to talk about solving equations, all right? We're going to do that. Let me see here. Let me bring it up. All right, here's our first example. We've now officially moved into one section, chapter 1, section 5, which is solving equations. And we want to be able to solve this equation. All right. So remember, solving an equation means that you're trying to find the value or values of a variable that make a statement true. The most basic type of equation that you've dealt with in your life is something like this: x plus 1 equals 3, right? So define the solution means to say, what do I plug x in? What do I plug in here for x to make that equation true, right? Obviously, you can just look at that and you can say that the answer is 2, right? 2 plus 1 is 3. But we know that equations get more complicated where you can't just look at them and see the answer. So we have to have a set of steps, a set of like a procedure to solve equations. And the equation that's being presented to you right now is what we call a radical equation, all right? Radical equation, because it involves the cube root of something. Now, does anybody know how we solve radical equations? There's a set of steps. There's a procedure. Anybody know what the first thing you want to do when you're trying to solve a radical equation is?
Move the 2 to the other side.
Move 2 to the other side. That is correct. Now that step is actually called isolation of the radical. So we want to isolate the radical. Okay, that's step 1. So that would mean here for us, add 2, so that our equation looks like this. Cube root of 2x minus 4 equals 2. We have isolated the radical. It's by itself, right? It's the only thing on one side of the equation. Everything else is on the other side. Who cares what that is? We've isolated the radical. That's first step. All right, somebody else? Let's see, Desiree? Do you happen to know what the second step would be?
I'm not 100% sure.
Okay, well, let me help you then. You see this radical, this cube root of 3 thing?
Yes.
It would be really nice if it wasn't there. So is there anything that you could do to both sides of the equation to make the cube root go away?
Multiply them, like multiply the 2 to the cube.
Okay, cube, right? What you do is to get rid of the radical, you have to cube both sides of the equation, all right? So our step 2 is to raise both sides of the equation to power which kills the radical. I'm sorry to be so violent with my language. All right, here we go. So we are going to take the cube root of 2x minus 4. And Desiree says we are going to cube that side of the equation. And then also we will cube the right-hand side. Now, the whole purpose of this is to kill off the radical, right? Because this was the cube root. When you cube a cube root, they wipe each other out, right? And then all you're left with is what's underneath. So what's underneath is 2x minus 4. And on the right-hand side, you still have to cube the 3, right? I mean, sorry, cube the 2, which is 2 times 2 times 2, which is 8. You good? Third step, solve the remaining equation. So when you're doing a radical equation, you isolate the radical, you raise both sides of the equation to a power that will kill off the radical, and then whatever happens after that is going to be an equation that you just need to solve. Fortunately for us, the equation that we still have, or the equation that we're left with, hopefully looks familiar, is a linear equation, because the highest power we see on x is 1, right? And linear equations are the easiest equations of all equations to solve, because all you have to do is isolate the x. So this is something I would expect you could all do. Add 4 to both sides of the equation, get 2x equals 12. Divide both sides by 2, and you get x is 6. And that's it.
I
Who
have
has
a
it?
quick
Yeah.
question.
Uh-huh.
If the exponent was, say, the cube root was like a 4, would it need a 4 to cancel out?
Yes.
Okay,
So
yeah,
if this
or if
was
it
a-
would be a 2 and another 2 would cancel?
Yep. So if this was a square root, we need a 2. It's a cube root, so we need a 3. If it was a 4th root, we need a 4, right? But as a power, just remember it's a power that we're bringing in. Now, I thought you were going to ask me something else, but there's something I need to say about this that's very important. When you raise both sides of the equation to that power, you need to look at that power, and you need to be very careful with that power. So let's see, Adam, are you there? Wait, Adam, I think, did I call Adam already?
You did.
I did. Okay, Adam, maybe you can help anyway. when you raise both sides of the equation to a power, is there anything that you have to be careful with on that? With that, like we raise both sides to the third power, we work through the problem, we got an answer, we're happy. Will it always work that way? That we can just like do that and be happy?
Sometimes the other side will like, instead of just be like a simple answer, it'll be a lot more complex.
It could be complex, could be complex. What I'm referring to though is something, and I asked you because I'm curious if you remember this and all. When you raise both sides of the equation to an even power, an even number like 2, 4, 6, 8, 10, anytime you do even on both sides as a power, you must check your answers. Okay, if you do an odd power, you don't need to check your answer. But if it's even, if that power is even, check answer. Check answers. The reason why you have to check your answers if it's an even power is because you may introduce what are called extraneous solutions. Let me illustrate, okay? I'm gonna give you an example, all right? Where we're gonna have to check the answers. Now, we didn't do an even power here. We did odd, right? 3. So we don't need to worry about checking the answers. The only answer we have is 6. We proceed. Next problem. Maybe. All right, solve the radical equation. First step, Lizana, is it Lizana? Lizana? Yeah, Lizana.
Yeah, Lisana.
Lizana? All right, Lizana, we have a radical equation. Now, had they not told you it was a radical equation, had they not told you, you would have to recognize it because of the radical, right? Because of the square root, you would need to know, oh, that's a radical equation. So our first step, Lizana, is to do what? What was the first step for radical equations?
Isolate the radical.
Isolate, okay. So is the radical isolated right now? Is it by itself on one side of the equation?
Yes.
Yes, okay, so check, it's isolated. We don't need to do anything. Second step. You want to keep going?
Yeah, get rid of the radical by raising both sides.
We're going to raise both sides of the equation to what power, Lisana?
Second power.
Second power, because it's a square root, we will go squared here, and we will go squared here. Now, Lisana, are we going to have to check our answers?
Yes.
Yes, because we did an even power on both sides. Okay, so let's go ahead and do this. Well, I'll let you go one more step, Lisana. So what is the left-hand side of this become?
X minus 1.
X minus 1, okay. And then on the right side, Lisana, what are you gonna have to do? This is not as simple as just squaring each one, right?
Foil?
Foil, yeah. So I'm gonna do that over here on the side. Here, 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 dot, dot, dot. I'm not even gonna show that work down, okay? I'm just gonna write down what it is. So this comes from doing this. I trust that you can do that now. We good? Everyone good? Okay, good. Lisana, you're off the hook. Clarissa, I think you're up. I'm sorry if I've already called on you.
You haven't. It's okay.
Okay, all right, Clarissa. What do you see in front of you? Because the third step is to solve what's left, right? So what kind of equation do you see in front of you?
I'm spacing the name for it right now.
Is it not, is it linear? Is it just a simple line?
It is.
Do you have, so linear, like in the previous one, linear came from the idea that the highest power we see is 1 on the X. Here, what's the highest power that you see on X?
The X squared.
X squared, right? Which means that it's not linear, it has to be quadratic, right? This is a quadratic equation. Does everyone see that? This is quadratic. And so the question now becomes, how do you solve quadratic equations, right? How do you solve them?
Would it be
Well,
by factoring?
You can either do factoring, or there's also, if all else fails, what do we have?
Quadratic formula.
Quadratic formula. So we're going to use one of those two methods, but the first thing you always do is get everything to one side. So what I'm going to do here is I'm going to subtract x on both sides. I'm going to add 1 to both sides. And that way my new equation becomes 0 on the left equals x squared minus 15x plus 50. So I just moved everything to the right-hand side. That is kind of the rule of thumb when it comes to quadratic equations, move everything to one side. Also, I'm going to write it kind of different. I'm going to put the 0 on the other side because it really doesn't matter which side the 0 is on. That looks more like what we've seen in the past. And now you either factor or you have the quadratic formula. I'm going to try and factor this real quick. I have 50 here and I have negative 15 here. So I think negative 5 and negative 10 work. And so I'm not going to show this step. Again, this is stuff I would say, oh, you can do that step now, factor it, do all that work. You should get these two factors. This factors to be this. And once we've done this, just Tavi.
Yes.
Tavi, right? It's Tavi, right? Tavi.
Yeah.
Okay, I need to put like 3 E's on the end of that so I say it right. Tavi. Okay, so Tavi, once you've factored it and have it equal to 0, what do you do next?
I'm kind of stuck on this part.
Okay. So we're saying that this, right, x minus 5 times this must equal 0, which means that one of these has to be 0. So you're going to take each factor and set each of the factors equal to 0. Does that ring a bell, Tavi?
Yes, it's coming back now.
Okay. So you set each factor equal to 0. And these are just little linear equations. You can just add 5 to both sides here and add 10 to both sides here, and you get 2 solutions, 5 and 10. Any questions on this part here or anything leading up to this? Who was it that I called on? Who told me to square both sides? Was that Carissa? Or was that Lizana? Who was it? Lizana? You told me to square both sides, right?
Yeah.
And didn't you tell me I was going to have to check my answers?
Yes.
Yeah, I'm not done then, right? I have to check these answers. One of them could be extraneous, or they could both be extraneous. I have to make sure that they satisfy the original equation. So I'm going to take this original equation, put it right here so we can see it, and I'm going to check it. So I'm going to plug 5 in first. If I plug 5 into that, let's see what we get. 5 minus 1 equals 5 minus 7. 5 minus 1 is 4, so square root of 4 equals 5 minus 7 is negative 2. The square root of 4 is 2. Wait a minute. 2 doesn't equal negative 2, right? 2 does not equal negative 2, which means this is not a solution.
Isn't negative 2 technically a square root of 4?
Good question. Hang tight, Josiah. I'll answer that in just a second. So now over here, we check 10, right? So let's check that one. Square root of 10 minus 1 equals 10 minus 7. So I'm just replacing the x's with 10s. That's square root of 9 equals 10 minus 7 is 3. And yeah, the square root of 9 is 3, and 3 equals 3. Check. Which means 10 is a solution. So our only answer is 10. All right, we have to throw out the 5. Anytime you raise both sides of the equation to an even power, you must always check that. Always. It sucks, but you have to do it, right? Okay, so Josiah asked a very good question about this square root of 4. So let's talk about that. So the square root of 4, is that equal to 2 and also equal to -2? What do y'all think? This is an excellent question because most people don't know the answer to this question, right? And it's confusing because you're told something about square roots and plus minus. Remember, you always hearing about, always do plus minus. You remember hearing about that? So
Yes.
I'm so glad that you asked this question. I would have brought it up at some point, okay? Just we're going to talk about it a little sooner than I thought. All right, so let's get this clear. 2 different scenarios. If I write down the square root of 4, the only answer to that is 2. Okay, the square root of 4 is 2. We call that the principal root, okay? The square root of 4 will always be 2. It will not be plus or minus 2. So that answers Josiah's question about, could that have been -2? The answer is no. But when do we get that plus or minus thing? So watch this. What if I had this equation, x squared equals 4? What if I started with that equation right there? Okay, and I ask you to solve it. Well, the first thing that you would do is take the square root on both sides to get rid of the x squared. When you do that, the x squared in the root goes away and you get the x, right? But then you have to do plus or minus the square root of 4. And that will give you 2 answers. That'll give you +2 and -2. The difference between these 2 scenarios is the one on the left, the square root of 4 was just there, right? It was just there. It was always square root of 4 from the very beginning. On the right-hand side, we made the square root appear, right? Like we were the ones who initiated the square root. The square root wasn't there in the very beginning, right? It was x squared equals 4. And then we did the square root on both sides. Whenever in algebra, calculus, going on, doing math, anytime you initiate the root, you got plus or minus. But if the root is just present within the expression, it's always just the principal root, which is the positive number. I hope that in some way clarifies any confusion you have. Okay, how are we doing? 228.
So is there always only just one answer, or could both answers be correct?
No, you could have 2 answers. You could have 1 answer. You could have no answers. You have to check them all. So that's just an unfortunate thing, because it would be nice if I say, oh, you'll always have 1 answer. You check the first one's not good. The second one is. You have to check them each one, unfortunately. Okay, let's see if we can get through this one before the end of time here. Solve the radical equation. All right, Lorena. Is Lorena here?
Yes.
Okay, Lorena. Where is Lorena? Oh, there you are. Okay. Okay, Lorena. This is a radical equation. First step.
I forgot the name of it, but we do the parentheses and the 2 at the top to get rid of the square root.
Okay, that's the second step. The first step is to isolate the radical. Okay, we want to isolate. Always make sure you isolate the radical first. Don't just go squaring both sides. You need to get the radical by itself. Okay. But Lorena, do you see a problem with that?
Yeah, they're all underneath the square root.
Yeah. How many radicals do you have?
2?
You have 2 of them, right? So it wouldn't be possible to isolate a single radical. The only thing you could do is get both radicals, right? To one side. So here's what we're gonna wind up doing, all right? Now I'm gonna write it down first, and then I want you to, once I write it down, I want you to kind of see what we're gonna do. So what I did here is the one that was square root of 2x plus 3, I left it here on the left-hand side. The one that had the minus, I basically added it to both sides. And so what happened is on the left, I'm left with this radical, and on the right-hand side, the 2 joins up with this radical, and there's addition between them. It does not matter which way you write this. You could put the 2 here and the radical here, or just leave the radical and put the 2 here. It's your choice. So because I had 2 radicals, I have to choose one of them. And the one I choose, I leave it on one side, and then the other radical just has no choice but to go to the other side. All right? Okay, now, second step is to square both sides. Okay? Now, this is gonna suck, everyone, okay? Because what I have to do is I have to take the left side and square it. That's not gonna be a problem, because when I square the square root, it'll go away. The part that's gonna suck is this side. When I square the right side, I am not going to square each one. I must FOIL. I must expand that out. And that is going to be a pain. Do y'all see that? Because of the addition sign, I must go to the side and do some scratch work. I have to do the square root of x plus 2 times itself, square root of x plus 2 plus 2. That's what this means. Like I said, the left side's not a problem. 2x plus 3, I'm happy. But the right side's going to require some work. Go with me? Megan, is Megan here? Megan? I don't think Megan's here. I'm not sure Megan's in the class. Okay, I will take a volunteer because I think I've called on anyone. Is there anyone I didn't call on? I just want to make sure I don't lose like somebody's attendance, even though they were here. I called on everyone. Oh, wait, Christopher? Oh, wait, I called on Christopher, but Christopher didn't answer.
I'm sorry, did I miss you when you called me?
I think so. Christopher? All right, so I'll go ahead and call on you then. So how about multiplying this out, foiling it? Can you tell me what we would get here? Here to here, here to here, here to here, here to here. So start with the first one. What's the square root of x plus 2 times the square root of x plus 2?
I'm a little lost here.
Okay, okay. Someone want to help?
Would it just be x plus 2?
It would just be x plus 2. So when you multiply square root of x plus 2 times itself, right? That's the same as squaring it. And so the square root goes away, and all you're left with is x plus 2. That's just what that first multiplication looks like. So this first multiplication from here to here gives us that result. Then we have to do the square root of x plus 2 times 2, which means we'll get 2 times the square root of x plus 2. Then we have to do the middle one, which again is another 2 times the square root of x plus 2. And then the outer one is the easiest one. That's 2 times 2 is 4. Let me clean this up. X plus 6 plus 4 square root of x plus 2. So I put this 2 together with this 4 to get my 6. I left the x in front. And then the roots, these things, are the same. So I can put them together. I have 2 of them, and I'm adding another 2 of them. That means I should have 4 of them. Any questions on that? Got 5 minutes. You all right with that? That's just the right-hand side of this equation. X plus 6 plus 4 root x plus 2. All right.
The x plus 6.
I'm sorry?
The
The
x.
x plus 6. This 2 and that 4 together. I just added them up.
Okay, got it.
All right, here we are. So we follow the steps. We isolated the radical, but there were 2 radicals. So we moved one over, we isolated one. We raised both sides to a power. We squared, didn't we? So we'll have to check our answers. And then we've done that, and now we have a new equation. And the goal now is to solve this equation. But
Do we have to re-isolate the radical?
yeah, this is another radical equation. Right? That's an equation. It has a radical in it. And so we actually have to go through the entire process again. So, all right, well, this is your reality now. So here we go. Minus x minus 6. I'm moving these over to the other side. So I'll have x minus 3 on the left equals, and then on the right, I still have a 4 in front of the square root of x plus 2. So I pretty much have the radical by itself, except for that 4 that's in front, right? That 4 in front. But it's okay. At this point, we can square both sides. Are there any questions on how I got the x minus 3 or why I'm moving things over? I'm re-isolating the radical. I have 3 minutes. Square both sides. So here we go. I'm going to square the left side, and I'm not going to show the work for it. I'm just going to trust that you could get it. I'm not expecting that you could do this in your head, but I do expect that you could get this for the left-hand side, dot, dot, dot. Then on the right-hand side, be real careful here. When you square this, because this is multiplication right here, you will square the 4 and then you will square the root. So if I square 4, I get 16. And if I square the root goes away and I'm left with the x plus 2. So square the 4, get 16, square the square root, the square root goes away, but the 16 will still have to distribute through. Okay, here I am. I'm going to stop at this point. What kind of equation do we have?
Quadratic.
Quadratic.
So now you need to solve that. So that means get everything moved over to one side. Maybe I'll go one more step. So I would distribute the 16 through here. And now move everything to one side, and you're either going to factor it or you're going to use the quadratic formula. All right, it's 2:39. I'm going to put dot, dot, dot. How about this? Y'all, you'll need to be able to get to the online homework. I will go in there and make any adjustments. Let me look at it real quick on the homework. Where is it? Hang tight, hang tight. Assignments. No. I think I told you I haven't taught this class in like many years, so I'm not used to this system yet. I'm trying to get acquainted with it. So equations, I just want to preview it. I just want to kind of see how far you can get into this. Okay, solve this equation. So isolate the radical, cube both sides. That shouldn't be a problem. I mean, not that it shouldn't be a problem, but yeah, isolate, square both sides, isolate. That's like the problem we're doing right now. That's a tough problem right there. Have not done that one. Or that, or that, or that. That one we have, that. Okay, so we're real limited here. I would say for homework 1.4, I would only expect that you do the first 4 questions. All right. So try and do the homework for the other sections. So for the algebra, polynomial, rational, really what I'm most interested in is that you can do the homework for rational expressions, nth roots, rational exponents, and then this one just 1 through 4. I'm going to change the due dates here on these because these were supposed to be due on the 25th. So I'm going to change all those due dates to, well, for all the R's, I'll push it till Monday. And then for the 1-4, I'll push it back also because we didn't get to it. All right. All right. You're free to go. Have a good weekend. Do your homework. If you don't know what you're doing, ask questions, come to my office hours. Anyone want me to hang out and try and help them get on to the ebook or any that? Who was having that issue?
Me?
Do you want to try it?
Yes, please.
Do you mind sharing your screen? That's
No.
okay.
Yeah, I mean,
Okay. All right, let me clear this out. Anybody else have a quick question before I?
Yes, this is on Canvas, correct? It's not like Pearson or anything.
What's that?
The homework. It's gonna be
Homework's on Pearson.